Hello GATE aspirants. Welcome to part 9 of GATE Mathematical Physics series. Question 1. The eigenvalues of a Hermitian matrix are all. So for Hermitian matrix, if you consider eigenvalue equation, h of psi is equal to lambda into psi, then we can take complex conjugate on both sides. So complex conjugate on both sides. So this will be complex conjugate of psi into h of psi. And lambda is scalar quantity, so its complex conjugate will just be conjugate of it into psi. So this is a Hermitian matrix, so complex conjugate will be equal to the same matrix. So psi Hermitian h is equal to lambda star into we have psi Hermitian, psi diagonal. So this is our equation 1 and this is our equation 2. Let us multiply equation 1 by psi diagonal. So from this equation we will get psi diagonal h psi is equal to lambda into psi diagonal psi. And from this equation let us multiply on the right hand side by psi. So psi diagonal h psi is equal to lambda star into psi diagonal psi. Now left hand sides are same, that means right hand side should also be same. That means lambda is equal to lambda star. So that means lambda is real. Its complex conjugate and that lambda is same, so lambda is real. So option A is correct. Next question. In spherical polar coordinates r, theta, phi, the unit vectors theta cap at 10, pi by 4, pi by 2 is. Now r cap, theta cap, phi cap, x cap, y cap and z cap. First write here sin theta and cos theta. Then you have cos theta here minus sin theta. Then fill in phi. So this will be, first will be cos phi, here also cos phi, then here cos phi, then sin phi and minus of sin phi, and here 0. So theta cap is equal to this part. So this will be cos theta, then we have cos phi x cap plus cos theta sin phi y cap minus sin theta z cap. So cos of theta is pi by 4, cos of pi by 2 x cap, cos of pi by 4 sin of pi by 2 y cap minus sin of pi by 4 z cap. So cos pi by 2 is 0, cos pi by 4 is 1 by root 2, sin pi by 2 is 1, y cap minus 1 by root 2 z cap. So 1 by root 2 y cap minus z cap. So option D is correct. Next. The scale factors corresponding to the covariant metric tensor Gij in spherical polar coordinates are. Now we have dl bar is equal to dr r cap plus rd theta cap plus r sin theta d phi cap. So we have here 1 r and r sin theta. So option D is correct. Next, given v1 bar is equal to v1, v2 bar are given. Which one of the following v3 makes v1, v2, v3 a complete set for a three-dimensional real linear vector space? So that means these all should be linearly independent vectors. So this determinant v1, v2, v3, it should be not equal to 0. That means they will be linearly independent. So we have to check for all the options. So first one we have 1 minus 2. So 1 minus 1 0. This is v1. Then minus 2 3 2 is second. Now for the first option we have 1 1 4. This is equal to 1 into 12 minus 2 plus 2 into minus 4 plus 1 into minus 2. That is 10 minus 8 minus 2 is equal to 0. For the second case, 1 minus 1 0 minus 2 3 2. Here we have 2 minus 1 and 2. So this is equal to 1 into 6 plus 2 plus 2 into minus 2 plus 2 into minus 2. 8 minus 4 is equal to 0. So this is linearly dependent. This is also linearly dependent. Now for the third case, 1 minus 1 0 minus 2 3 2. Then we have 1 2 6, which is equal to 1 into 18 minus 4 plus 2 into minus 6 plus 1 into minus 2. So that is 14 minus 12 minus 2, which is equal to 0. So linearly dependent. Then we have 1 minus 1 0 minus 2 3 2. Last one is 2 1 4. This is equal to 1 into 12 minus 2 plus 2 into minus of 4 plus 2 into minus of 2. So that is 10 minus 8 minus 4, which is minus 2, which is not equal to 0. So it will be linearly independent. So this vector can be basis for the linear vector space. Option D is correct. Next question, 44. Given this equation is given d2f by dt square. So this is d square minus 2d plus 1 into f of x is equal to 0. And boundary conditions are given. The value of f of 0.5 is. So this is d minus 1 square is equal to 0. That means d is equal to 1 1. So this function will be c1 plus c2x into e raised to 1 into x. Now here it is given that y of 0 is 1. So this will be simply c1. So c1 is equal to 1. So y function will be 1 plus c2x into e raised to x. Now y of 1 is equal to 0. So that means 1 plus c2e is equal to 0. So that means 1 plus c2 is equal to 0. That means c2 is equal to minus 1. So y function will be 1 minus x into e raised to x. So y of 1 by 2 will be 1 minus 1 by 2 e raised to 1 by 2. So half into e raised to 1 by 2. It is equal to 0.82. So up to 2 decimal places 0.82, and answer given in the answer key is 0.81 to 0.84. The absolute value of the integral over this circle in a complex plane is. Now this is the plane. This is 0, 1 and 2. Then its center is at 1.5. So here it is having center and its radius is 1. So it will be like this. This will be the circle. Now let us find out singular points. So z square minus 4 is equal to 0. So z square is equal to 4. So z is equal to plus minus 2. So plus 2 lies in this curve. So z is equal to plus 2 lies inside the curve. And minus 2 is here. Now residue at z is equal to 2. It will be equal to numerator as it is 5z cube plus 3z square and upon derivative of denominator, that is 2z at z is equal to 2. So this will be 5 into 8 plus 3 into 4 upon 2 into 2, 4. So this will be 5 2s are 10 plus 3, that is 13. Now I is equal to 2 pi I into residue, which is 13. This is 26 pi I. 26 into 3.142 into I. Absolute value means you have to just find out its magnitude. So this is 26 into 3.142, it is 81.69. And answer given in the answer key is 81.60 to 81.80. So these were all the questions from GATE 2018 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.